solving a system, you're trying to find out where do the lines cross. What point do they have in common? So sorry. I did not mean to do that. It's the same equations in every single problem. So the question we're asking is, where do the lines cross? What point do they have in common? Well, that was pretty faint. Alright, so we have to graph these two equations for number one. And we want to graph them on the same coordinate plane. I know you're working on a notebook, that's okay. I'm just going to do the best I can to make a nice straight coordinate plane. So how can we graph this first line, x plus y equals 4? So this is called the standard form, because x and y are on the same side. And this one's called slope-intercept form. So we have to graph standard form and slope-intercept form. So Romani, do you have any ideas about how I can graph x plus y equals 4?
No. I know how to do the second one.
Oh, good. You know how to do the second one. Should we start with the second one? Let's just start with the second one. Okay, that sounds good. Good plan. So we're going to graph y equals 2x minus 2. What do you do to do that one? Okay, and then what?
And then go 2 over 1.
Very good. 2 over 9 is over 9. All right, good. We can do that. So this is where I begin. I begin at that -2 on the y-axis. And I go up 2 over 1. Up 2 over 1. Up 2 over 1. All right, there it is. That's the second equation. Okay, Calista, what strategy did you use to graph x plus y equals 4? Then I did y over 1, and I got 4 down 1 to 7. Okay, that's good stuff. So you can rearrange it so that y is alone. So what she did was she started with x plus y equals 4, and then she has this idea in her head to make it look like y equals mx plus b. So she rearranged it to get y alone. And y would be negative x plus 4. And then you can use the same strategy to graph that. The question on the exam was solve for y. And that's what you're doing there. That's that scale. Can I tell you another way to do it? We're interested in the other way. The other way to do it is in standard form, is to use the intercept. So you could plug in x equals 0 and solve it, and then do it again and plug in y equals 0 and solve it. So in standard form, this sometimes is a good strategy too. So this would be 0 plus y equals 4. So that's y equals 4. So I could put a point at 0, 4. And this is x plus 0 equals 4, x equals 4. So I could put another point at 4. So this is using intercepts, x and y intercepts. And if I do that or that, it'll come out the exact same line. Okay? Okay, now what are you looking at? Are there any of these now? So who wants to graph like this where you begin at 4 and you go down 1 over 1? Who wants to graph that way? Okay, who wants to do the intercepts and plot 0, 4, 4, 0? Couple of you. Alright. I'm gonna do both. I'm gonna do this one in yellow. You have to do one. So we have to make another graph. So really don't need this. Alright, so this one, if I graph this one, I start at 4 and I go down 1 over 1. I begin at 0, 4, and I move down and start here, down 1, right 1, down 1, right 1, down 1, right 1. And I go the other way, up 1, right 1. And here's the answer I'm looking for. At 2, 2, these two lines cross. That's the point I was trying to find, where the lines cross. Now, using the intercept method, it's the same line as the green one. I have a point at 0, 4, and I have a point at 4, 0. And I just connect those. And that's the x and y intercept form. So I just reviewed 2 ways of graphing. You can graph using the intercept and slope, or you can plug in zeros and plot 2 points and graph. Is that too much at once? Just pick one. Pick one that you like. Alright, so that's it. We know the answer is 2, 2. That's where the lines cross. That's the solution. So the way to test that is I could check it myself if I was questioning, oh, maybe my graph is crooked or maybe I didn't do it right. I should be able to put 2, 2 in here and it comes out true. Notice if I put 2 for x and 2 for y, 2 plus 2 make 4. So that will justify my answer. Okay, you can check a lot of stuff by plugging in. I can also plug in 2 in here and here for x and y. This would be 4 minus 2 equals 2. So this ordered pair x and y works in both of those equations. It's a solution for both of them. You can always check by plugging in and see if it's true or not. Okay? We're going to solve that now without graphing. We're going to solve using substitution. We're going to do the same thing in a different method. Sometimes graphing just is no good. This worked out nice because it connected at a very clear point. Sometimes it kind of connects in the middle, it's a decimal, it's not as good. Okay, substitution. So I need to be able to pull a replacement in. So when I look at this bottom, it is y is 2x minus 2. When you read is in a problem, that's where the equal sign goes. So y is the same thing as 2x minus 2. Y is 2x minus 2. So what I'm going to do is I'm going to substitute that in. I'm going to kick this y out. And I'm going to put this whole expression in. And that's a substitution. It's a whole expression substitution. So what will be new equation would be x plus 2x minus 2 equals 4. That's what a substitution is. Now you solve that. It's not too tricky. Combine like terms. X and 2x is 3x. Yeah. And now I'm getting x alone, so I would add 2 over. I would get 3x equals 6. Divide by 3. X equals 2. X equals 2, and that's what I got in my ordered pair. X is 2. Anybody remember doing that? The thing is that you don't stop. You must find y. Don't stop. Find y. How can we find y? You plug it in. You can plug it to the top, or you can plug it to the bottom. Either one you pick. I'm going to go ahead and I'm going to plug in the original equation. So I'm going to go to any one of the originals and plug in. So it would be y equals 2 parentheses 2 minus 2. Y equals 4 minus 2. Y equals 2. And so here I am. X and y are 2, 2 again. There. I don't know. The first one, the graphing, it kind of did seem easier. But to be honest, these are meant to be easy to graph. Actually, I like the substitution too. Yeah. Does anybody like the substitution better than the making the graph? Correct. You can do the top or bottom. It's whatever you choose. So many multiple ways to solve our algebra equation. Lots of problem solving. Okay, so we've done it twice. We found it graphing, then we used the substitution method up here. Last one, elimination. It's gonna look like the most work, but sometimes elimination is really the easiest. And the so the EOC is gonna be real clever. And my prediction is that they're going to. There's one like this in your practice exam. They're going to show you like some steps of one of these, and you would have to know like the right move. And if it's a word problem and it's a system, you can pick whichever. But I mean, they say that you're supposed to be able to pick whichever, but from a teacher's perspective, I can tell which one I'm trying to get you to do. Anyway, elimination. You always have time to like problem solve, right? So even if it tells you to do one way, you could problem solve a different way and try to figure out that way. So do what you're comfortable with and then go back. Okay, for elimination, you need opposite. And your opposite could be either x or y. Also, for elimination, they have to be lined up the same way. Must be lined up. And normally, you know, set up line up for you. So I'm going both in standard form and just see if you guys can come up with the opposites from there. So I'm going to keep the top one the same. And I'm going to take the 2x over. And this is what I want you to try to do elimination. So I rearranged this one. Okay, I want to be able to add down and something cancels. I'm going to put a big line through one of these. So what should we make opposite? We could multiply the whole top by 2 and have positive x's. We could multiply the whole bottom by -1 and have opposite y's. Winter, what are your thoughts? How would you like to make opposites? Yeah, I think you were pretty good at this. We need either opposite x's or opposite y's.
I don't have no idea what you're talking about.
So pick a variable and I'll work it out. You want to do x or y?
Oh, we can do X.
Let's do x. Okay. So the bottom here has a -2x. So to make an opposite up top, I'm going to multiply the whole top by +2. The top equation will be 2x plus 2y equals 8. And the bottom equation stays the same. Now go ahead and write it down like this, Winter. There's a good chance that the problem's going to be set up nice like this for you. Okay, so if you checked out when I was talking about all this, fine. Check back in right now. Write this problem down and finish it. There's a good chance it'll present correctly. JY, write this red problem down and finish this one. Okay? I don't care. I don't care if I lost you in the first 3 things I said here. Just do this red problem. There's a good chance it could be as simple as this red thing. Okay? So, okay then, write this red problem down and do it. If it's set up for you, I want you to be able to do it for sure. Okay? Everything I said here was setting it up. It's a little more advanced. If it's set up for you, you should be able to do it. Just creative thinking. So if this was a 3, I would have done the top by 3. Okay? Yeah. And when we did this in November, we did lots of repetitions, and you guys were pretty good at it. Okay? I think there's one in your.
Why is the 2 negative in the coefficient?
Oh, right. So this was the problem right here. Right? As given on the screen. To do this method called elimination, the x has to be over x, the y has to be over y, and the constants have to be over each other. So here I subtracted 2x from both sides. I rearranged it. Hopefully, on something like an exam, I'll already rearrange for you, but I rearranging is part of the skill.
What would it, on the exam, how would it word it? What's the problem?
You know what I'll do is I'll look up some questions. Because you're probably right. You probably won't see something so clearly as solved by elimination. So let's look up some directions.
Do you think it'll be written like that in red?
I think it'd be a little easier in this way. It might not be. It could look like this. No. It may not be.
So I guess this about the 2, wouldn't it be like
This red one? Yeah. Well, since this one is already negative, I would do something opposite.
So if it was a positive,
I'd do a negative. Okay, so when I add down here, I have opposites. This is eliminated. I set this up so it could be eliminated. 2y added to 1y is 3y. Equal sign, 8 minus 2 is 6. Some point I should have a little bit familiar. Now I'll divide by 3, and I get y equals 2, which is exactly what I got when I graphed these and when I did substitution. Same answer, different method, but it's all the same problem. Those are the same equations. You're given two equations. You typically have to adjust one of them. It might be a slightly easier adjustment than what we just went through, but it'll be just good. Why? Well, you never stop. If you're solving a system, you need x and y. We're not going to stop. Find x. So how are we going to go about finding x now? Plug in. Yeah, you just plug in. You're going to take this 2, you can put it into either of the originals. So you can put it in here. I think Calista favors that. Or you can put it in here and find x that way. So you pick where you want to plug in. Plug into the original. So find x. So I'm just going to do x plus 2 equals 4. Subtract 2 from both sides, and there it is. X is also 2.
Where did you get the
This thing? What?
The one right under the
8 minus 2, 6. So 2y plus 1y is 3y. And I divided both sides by 3. Because this is 3 times y, the opposite of times is divided. So I divided it to get y11 plus 6y over 3. Good, that's a really good job. What I'm going to do is you guys log into Big Ideas Math. You guys are going to work on some more exam questions. I'm going to pull up some wordings of how a system equation might be asked.